Hello, chemistry students. Today we're going to be talking about ionic compounds, which are substances that are formed when more than one type of element comes together and trades electrons to become positively and negatively charged. So, we previously discussed how atoms can become ions by either gaining or losing electrons, and they do this to achieve a full shell of 8 valence electrons to become stable like the noble gases. Metals, which tend to have a low ionization energy, tend to lose electrons to become positively charged. And this is because the protons will then exceed the number of electrons when those electrons are lost. And these positively charged ions are known as cations. Since nonmetals have high ionization energies, they are more likely to gain electrons than lose them because of the high cost to remove them. And when they become negatively charged ions, when the electrons exceed the number of protons, they become known as anions. And then a quick note about anions: when a nonmetal becomes an anion, we change the ending of its name to "ide." For example, when oxygen becomes 2 minus, we call it oxide. So when a electron is lost, where does it go? When an electron is gained, where does it come from? Well, in order for these processes to actually happen, you need more than one type of element. You need both a metal and a nonmetal. Because if a sodium atom is going to lose its electron, that electron has to go somewhere. Well, there are certain things that would benefit from that electron. It's like a chlorine atom, which has 7 valence electrons that just needs one more. So there actually is a tendency for metals and nonmetals to come together where the metals will lose their electrons and then the nonmetals will gain those electrons. So if a sodium atom is to come in contact with a chlorine atom, the sodium atom is going to shed its outside electron to get a full outer shell, and then the chlorine is going to gain that electron to get a full outer shell, and then we get what's called an ionic compound. We get a substance where we have both sodium positive ions and chlorine negative ions that come together and form a larger structure. The process of the electron being given from one atom to the other, creating a subsequent attraction between them because one is positively charged and one is negatively charged and they're going to stick together. This is called an ionic bond. And this is formed whenever a transfer of electrons from one atom to another results in those two atoms sticking together to form a larger structure. And when an ionic bond occurs, that larger structure becomes what's called a crystal, something that has a repeating 3D geometric structure. So if you look at this visual down here, these little gray circles represent the sodium cations, and these green circles represent the chloride anions. We end up having a predictable repeating geometric structure where they're alternating positive, negative, and being all attracted to each other. So this resulting substance is what we call an ionic compound. And note that the word compound always means that you have more than one element. So you can't have a compound with only one type of element. And when we name this ionic compound, we always name the cation and then the anion. So the name of this compound is going to be known as sodium chloride. Note that we don't change the name of the cation, only the name of the anion. And it's always cation first, anion second. And this is what you might know as table salt, the like salt you put on your food. We also give it what's called a chemical formula, which is a combination of the elements written like this that shows you how many of each of the elements came together to form that structure. So even though there's a ton of sodium and chloride ions in the overall structure, they are in a 1-to-1 ratio. We need 1 sodium per every 1 chloride. So it'll be written as NaCl. So the structure of a substance is dependent on the ratio of the atoms, and sometimes it's not 1-to-1. So for example, magnesium, which is an alkaline earth metal, which is in the second column on the periodic table, has 2 valence electrons. So it'll have a tendency to lose 2 to get a full outer shell. But since chlorine only needs 1, if Mg and Cl are going to bond, one Mg atom is going to give 1 electron to one chlorine atom, and it's going to have 1 left over. So it's going to be able to give a second one to a second chlorine atom. So the resulting structure is going to have a single magnesium 2+ ion attached to 2 chlorine 1- ions. So the substance is going to be called magnesium chloride because we named the cation and then the anion. And its formula is going to be MgCl2. Note that we have a little subscript 2 next to the chlorine. Whenever we need more than one of an atom, we're going to use a subscript, which is like a little number here. So this tells us that we have 2 chlorines per every 1 mg. And the charge on an ionic compound should always be balanced. If you think about the last example of sodium chloride, the sodium was positively charged and the chlorine was negatively charged, and a positive and a negative make 0. In this case, we have 2 plus and then 2 1 minuses. So 2 plus -1 will be 1 plus another -1 will be 0. So it becomes neutral as a result. So now let's see what this looks like in terms of Bohr models. Let's take a metal, lithium, and a nonmetal oxygen and see how lithium and oxygen are going to form lithium oxide. And from that, we'll also be able to figure out what its formula is. So if we draw a lithium cation, it has 1 valence electron, which is going to give up to the oxygen, which is then going to have 1, 2, 3, 4, 5, 6, 7 with the additional electron. It still needs 1 more. So we're going to need a second lithium atom. So that's going to give up its electron. So now both these lithium atoms are going to have a full outer shell, which is 2, which is a specific circumstance for lithium and beryllium. They don't need to have 8. They just need to have the full outer shell, which is equal to the helium atom. So then we're going to have a lithium cation, which is positive, or 2 lithium cations, which are positive, and then 1 oxygen anion, which is negative with a 2 minus charge. And then 2 minus plus 1 plus is 1 minus, plus another plus is 0. So we become neutral here. And often when we draw the charged Bohr models, we give them a square brackets with the charge of the atom on the outside, so we can know that it has either gained or lost electrons. And also, since we knew that there was a ratio of 2 lithiums per 1 oxygen, our chemical formula is going to be Li2O. Let's try another example with beryllium and nitrogen, also a metal and a nonmetal. So let's do the same thing here. Let's figure out how they're going to form beryllium nitride and then also figure out what their formula is. And also a hint here, we're going to look at the charge of each of the ions and figure out the common multiple of them. This will be a way to easily predict how much of each ion you're going to need to balance the compound, but I'll talk about that at the end. All right, so beryllium has 2 valence electrons, so it's going to want to lose 2. Nitrogen has 5, which means it's going to want to gain 3. So we start off with 1 beryllium, giving up 2 of its electrons to nitrogen, so that goes from 5 to 6 to 7. So now this nitrogen is going to want 1 more, and then this beryllium is good. That means we're going to need to bring in a second beryllium atom in. So that's going to give up 1 of its electrons, and now this nitrogen is going to be good. It's going to have the 8 that it needs in its full shell. However, this beryllium is going to have 1 more electron left over to give up. So then we're going to bring in a second nitrogen atom. We're going to give another electron to the beryllium. Started with 5, now it has 6. It still needs 2 more, but this beryllium is now good. So we're going to need to bring in a third beryllium. That's going to give up its 2 electrons, and then this beryllium will be good, and then finally this nitrogen will have 8, having gained 3 total. So we'll end up with 3 beryllium cations, 3 beryllium 2 plus charged ions, and then 2 nitride anions, both 3 minus. And since it was 3 to 2 ratio, we'd write the formula as Be3N2. We can also confirm that this was right based off of adding up the charges. We had 3 2 pluses, which will be 6 plus, and then 2 3 minuses, which will be 6 minus, and 6 plus 6 minus equals 0. So there will be times where I ask you to draw these Bohr models out and show how the electrons are moving to make the ions. But overall, if you want to predict what the formula of an ionic compound is going to be, you're going to want to look at the charges of the ions formed. Like what I mean by that is beryllium is 2 plus and nitrogen is 3 minus. If they're going to come together to form a neutral compound, those charges need to cancel each other out. So we need to figure out how we can get 2 and 3 to become the same. So we're going to want to think about common multiples. A common multiple of 2 and 3 is 6. So if we can turn the 2 into 6 by multiplying it by 3, and the 3 into 6 by multiplying it by 2, that'll tell us the ratio that we need of the 2 atoms. We're going to need 3 berylliums per every 2 nitrogens. And that'll do it for today's talk about ionic compounds, and I'll see you later.